Hi there. So we are solving equations, or actually systems of equations, by the addition method, what some people call the elimination method. Remember, here's the procedure. Make sure both equations are lined up the same way. Take one or the other or both of the equations and multiply through by the same number on both sides, whatever it takes, so that on whichever variable you're trying to eliminate, the coefficients are opposites. Same number, but one of them's plus and one's minus. Then add the equations together, which should eliminate that one variable. Solve to find the other variable and take that number and stick it back into one of the original equations and solve to find that second variable. So let's try this example. We have two equations here, 8x minus 2y equals 2 and 4x minus y equals 5. Let's see, I can eliminate the x's if I take the bottom equation and multiply it by negative 2. Because that would turn this into a negative 8 in front of this x to go with the positive 8 in front of the other x. So I'm taking that bottom equation and I'm multiplying by negative 2. The top equation can stay the way it is. I'll just move it over. So now the top equation is still 8x minus 2y equals 2, but the bottom equation, I multiplied everything on both sides by negative 2, and I got negative 8x plus positive 2y equals negative 10. Now I'm going to add these two equations together, and the 8x and the negative 8x kill each other off. The negative 2y and the 2y, they also kill each other off. They add up to 0. Meanwhile, on the other side of the equal signs, the 2 and the negative 10 add up to negative 8. So I've got the equation 0 equals negative 8. What does that mean? That's just plain not true. So that means that there's no solution to this system. It's an inconsistent system. Remember, if you eliminate both the variables at the same time and just get a contradiction like this, something that just plain is not true, that's how you know your system has no solution. Now, if this had been a 0 equals 0, which is true, an identity, that would mean that we have infinitely many solutions, because anytime one equation is true, so is the other. Okay, let's try another example. X minus y equals 1, and 2x plus 4y equals 5. Which variable do you want to eliminate? We could go either way. We could eliminate the x's. To do that, we would want a negative 2 in front of this x to go with the positive 2 in front of this x. Or we could eliminate the y's. If we want to go that way, we'd have to have a minus 4 in front of this y to go with the plus 4 in front of this y. We could do it either way. It's your choice. So multiply the top equation by either negative 2 if you want to eliminate the x's, or by 4 if you want to eliminate the y's. I think I'll do it by 4. Why not? So the bottom equation can stay the way it is. The top equation gets multiplied by 4, which turns it into 4x minus 4y equals 4. And now when I add these together, I get 6x equals 9. Now divide both sides by 6, and x equals 9 divided by 6, 9 over 6, which it doesn't come out to be a whole number, but as a fraction in lowest terms, it would be 3 over 2. Or if you wanted to write it as a decimal, it would be 1.5. So we got our number for x, 3 halves or 1.5 or 1.5. Stick that into either one of the equations for x. If I do it here, 3 halves minus y equals 1. Then if I subtract 3 halves on both sides, negative y would equal, and then 1, which would be 2 halves, minus 3 halves would be negative 1 half. If we were working with decimals, we'd be subtracting 1.5, and then 1 minus 1.5 would be negative 0.5. Then to get from negative y to y, divide both sides by negative 1, y equals positive 1 half, or positive 0.5. So our solution depending on whether you want to write it in fraction form or decimal form, is 3/2 for x and 1/2 for y, or 1.5 for x and 0.5 for y. And how about this one? Now here's one where the equations are not lined up the same way. The top equation has an x term and a y term equal to a constant term, and the bottom equation has an x term and a y term and a constant term all together on one side equal to 0 on the other side. So we're going to have to do some rearranging so that they are both lined up the same way. And why don't we get rid of the 9 here, just subtract 9 on both sides. Then we've got 10x minus 2y equals 30 and 3x plus 3y equals -9. Okay, now, we got to set things up so that the coefficients on either the x's or the y's are opposites. Same number, same absolute value, but one of them has to be positive and one of them has to be negative. We could do it with either the x's or the y's. I decided to do it with the y's. That seemed a little easier to me. So I multiplied the top equation by 3, which would turn this minus 2y into a minus 6y. That would mean that I need a plus 6y in the bottom equation. So I'm going to be multiplying it by 2. So when I do that, here's what I get. The top equation turns into 30x minus 6y equals 90. And the bottom equation turns into 6x plus 6y equals -18. Now don't forget, everything on both sides has to get multiplied. You can't just multiply some things and leave other things the way they are. Now, when we add the equations together, here's what we get. 30x plus 6x adds up to 36x. -6y plus positive 6y adds up to 0. They kill each other off just like we planned. And then the 90 and the -18 add up to 72. 36x equals 72. Okay, now to get from 36x to just x, divide both sides by 36. X equals, well, 72 divided by 36 turns out to be 2. What do we do with that 2? Are we all done? Is that our final answer? Well, that's only one of the variables. We need the y that goes with it. So take that 2 and stick it in place of x in either one of these equations. If I do the top one, 10 times 2 minus 2y equals 30. Well, 10 times 2 would be 20. So we're looking at 20 minus 2y equals 30. Keep the y term where it is, but get rid of the constant term by subtracting 20 on both sides, and we get -2y equals 10. Then divide both sides by -2, and y equals -5. So we've got our x and our y, and together they make up the solution to the system. X is 2, y is -5. That's what makes both the equations true.